Hey everybody, this video is going to go over how to calculate G to see if it is really around 9.8 meters per second squared. Remember, G is acceleration, how quickly on Earth something speeds up when you drop it. You can see that when I drop the marker it speeds up, but how quickly does it do that? And G is a measurement of how quickly it speeds up. So we've been using the equation D equals 1/2 times G times T squared to describe how objects fall. Alright? D is distance it falls, G is the acceleration from gravity, and T is time. Okay, and only the time gets squared in that equation. Okay, so in this lab, what did we use for distance? How did we get distance? The distance was your height. And I want you to plug in your height in meters for the distance when you calculate G, okay? The T, well, we measured time 5 times. We did 5 trials, and then we took an average. So I want you to plug in what you got for the average for time, okay? When I did my trials, I got that I have a height of 1.8 meters. Okay, so I measured it in feet and inches. I converted it to meters using Google, and then I got 1.8 meters. I'm going to plug that in. I want you to use the number you got in meters, not my number. Okay, your number is going to be a little different than 1.8. Then it equals 1/2. G is what we're going to solve for here. You're solving for G as well. And then T, what did we get for our average time? Well, for my average time, I got 0.6. Now, you didn't get 0.6. You probably got something close to it, something around there, something under 1 second. And plug in whatever you got for your average for time. Don't plug in 0.6, and whatever you got for distance for your height in meters, not 1.8, not what I used. Okay? Okay, now what's the calculation we need to do to figure out what G is, okay? That's our next step. So I'm going to carry this down. I'm going to write 1.8 equals, and on my calculator, I'm going to do 0.6 squared. Whatever you got for time, you square that number. So 0.6 squared, maybe you had 0.5, you do 0.5 squared. Maybe you had 0.7, you do 0.7 squared on your calculator. I got 0.6, so I did 0.6 squared, and I got, actually mine turns out to be 0.36. And then I'm just going to write the 1/2 G. I'm going to bring that down. All right, so we squared our time. And then I know these three get multiplied together, but I don't know what G is. So I'm just going to multiply these two. 1/2 times 0.36. You do 1/2 times whatever you have sitting right here next. Remember, it's a good idea to pause this video and do your calculation. So you didn't get 0.18, but whatever you got, 1/2 times whatever number was over here, you could write it in that parenthesis, carry it down. And then I'm going to carry down my distance, 1.8 I had. Okay. Now the last step is you have a number right in front of G, okay, and you're going to divide both sides by whatever that number is. I'm going to divide by 0.18. Okay, and G is the only thing left on that side. So then I have, it turned out to be 1.8 divided by 0.18. And I got 10 for G. Now it's pretty close to 9.8. Looks like I did a pretty good job being accurate with my measurements. And the unit is 10. It's an acceleration. So m over s squared is just the unit, okay? So just to review, what you need to do right now is plug in your distance and your time. Okay, square the time. You get a number around that's a little smaller than what your time was. And then you take your time, multiply it by 1/2. You get a different number. Remember, your time is going to be different than mine. Okay, and then you can divide both sides by that new number you get. And you get G, okay? Some of you are going to say, oh, I know how to do this already, and that's fine. Just wanted to help you out in case Just make sure you use your own distance and your own time. Don't use my numbers. Those are mine. Okay. Don't just copy this down and submit it as your lab. Okay. Make sure you use your distance in meters in your time, the average time you got, and plug it in and take the same steps that I took to get the answer for G. Okay.